Yes, so hello everyone. Welcome to another interesting session of the Astro Club. Today we have another interesting topic to discuss. The topic for today's session is Introduction to Rover Designing Part 1. So today we are going to discuss about rover designing. Means how we can design a rover. Okay, until now we know what the rover is, or we know what is the use of a rover. Am I right? Do you all know what a rover is, or what is the use of rover? We have been discussing. Yeah, so it is important to know how a rover is designed. It is very important to know how a rover is designed. So that is why I've chosen this topic, Introduction to Rover Designing. So before we talk about rover designing, just a small recap we will do. The small recap we will do on what is a rover and all of that. So let's see here. Yeah. So what is a rover? So a rover is a planetary surface exploration device which is designed to move across the solid surface on a planet or other celestial bodies. Or another simple definition is a rover is a vehicle for exploring the surface of a planet or a moon. So this is a picture of a rover. Some rovers are human powered while others are autonomous. Human powered in the sense one of the astronauts should sit in that rover and he should pedal that rover.
Control that rover.
Yeah, he should control that rover. So that is called human powered rover. And some rovers are autonomous. Autonomous means automatically those rovers will move by itself.
Machine.
Yeah, the rover will move by itself. There is no need of any astronaut to control that rover. So such type of rovers are called as autonomous rovers. And what is the purpose of a rover now? Rovers are mainly tasked to collect information about the terrain and also to collect samples such as dust, soil, rocks, and liquid. These are essential in space exploration. So rover collects all of these things like dust, soil, rocks, liquids, and all of those. Okay, so rover plays a very important role in space exploration. Because only if rover collects these samples, then we can understand about that planet or we can understand about moon and all that. Okay, did you all understand?
Yes, sir.
Yeah.
Yes, sir.
Yeah. So over the years, humans have sent many rovers into space. So some of the examples of rovers are Sojourner, Spirit, Opportunity, Curiosity, and Perseverance. So all of these are NASA's rovers. So these are examples of some of the rovers which humans have sent into space. And here is another picture of a rover. This is how a rover looks like. Next. Even our Indian Space Research Organization, that is ISRO, has developed a rover named Pragyan. Not only US, not only America, India has also developed a rover called as Pragyan, and it was launched along with Chandrayaan 2. But unfortunately, Pragyan was destroyed along with the lander Vikram when it crash landed on the moon. And so it never got a chance to deploy. We all know the story of Chandrayaan 2, right? The lander got crash landed.
Yes, sir.
Yeah. So along with that, Pragyan was also destroyed. Along with the lander Vikram, Pragyan was also destroyed. So it was not deployed onto the surface of moon. But ISRO has designed this rover. Its name is Pragyan. Okay, next. Along with US, India, there are also other space agencies like European Space Agency, Russia, and there are other countries which have sent rovers into space. Okay, so this is all the introduction about the rovers. So now coming into our topic. What is the topic for today? Introduction to rover designing. So introduction to rover designing. So what is the need for a specialized design? Why should a rover have a design? We might get a doubt. Why should there be a specific design for a rover? Now we'll talk about the need for a specialized design. So rovers arrive on spacecraft and are used in conditions very distinct from those on Earth, which makes some demands on their design. Okay, so when the rovers go into space and land on some terrestrial body such as Mars or any other planet, its conditions are not like Earth. Am I right?
Yes, sir.
Yes, sir. Not like Earth. Yeah, it's not like Earth. So that's why the rover has to withstand high levels of acceleration, high and low temperature, pressure, dust, corrosion, cosmic rays, and also the rover should function without repair for a few years. So rover should fulfill all of these conditions. That is why we need a specialized design for a rover. If there is no particular design, then all of these conditions will not be satisfied. And the rover can't work properly. That is why we need specific design. And there are a lot of conditions we should consider. We should consider about the design, we should consider about the shape of the rover, we should also consider about what materials we have to use while making the rover. Okay, all of these factors we have to consider. So that is why we need a specialized design. Did you understand?
Yes, sir.
Yeah.
Yes, sir.
Now, so NASA is planning to send human astronauts to land on the moon through its mission Artemis. Yeah, so NASA is planning a mission called as Artemis. Through Artemis mission, astronauts will land on the surface of the moon. And the astronauts will explore the moon by using a human-powered rover, which means the astronauts will only drive the rover. See, in this picture, an astronaut is sitting on the rover and he's operating it. So in the same way, in Artemis mission also, astronauts will be sent onto the surface of moon and they'll be using a human-powered rover to explore the moon. Did you all understand?
Yes, sir.
Yes, sir.
So now, so this is how a human-powered rover looks like. So there are two seats here. So two astronauts will be sitting on either side. And here there are pedals, right? So astronauts will be pedaling this rover in order to operate it. Okay, then. So now we look at the classifications. So module in the sense, this is a rover. So when we are talking about a rover or when we are researching about a rover, we should consider three important classifications. First, we need to get an idea about the components of a rover. Then we should get an idea about the functions of these components. Like what is the function of all of those things. And then we need to make a preliminary analysis. Preliminary analysis in the sense like complete idea of all the things we need for making a rover, like the materials, the cost, and all of those things. Okay?
Okay.
Yeah. So we should keep in mind these three
Okay,
things.
Akka.
Yeah, so we should keep in mind these three things while making the rover. So now let's look at the components of a rover. So there are mainly 5 components. That is the basic structure, the power unit, the transmission system, the controls, and the auxiliaries. So I know all of these terms are very new to you, but don't worry. Each and every term I will explain in detail, then you will understand properly. Okay? Yeah. So these are the main 5 components of a rover. So if you consider the basic structure, again in the basic structure, we have the subdivisions. See, this is the basic structure. Again in basic structure, we have 5 subdivisions. Okay, so we have the frame,
Okay, Akka.
we have the suspension, we have the system, suspension system, then we have the wheels and we have the axles. Are you able to see what I'm writing?
Yes, Akka.
Okay. So in basic structure, we have again these subdivisions. Now, if you come to controls, so controls in the sense, what are the things we need to control a rover? We need braking system and we need steering system. So these are the components of a rover. Today we are going to learn about the basic structure. So we are going to learn about frame, we are going to learn about the suspension system, and we are going to learn about the wheels. So let's get into the frame. Until here, did you all understand?
Yes. Yes, Akka.
So first, let's get into the frame. These are all very important things you need to know for designing the rover. Okay, so first frame. Frame or chassis. We can call the frame as chassis also. Like, I will write the spelling here so that you will understand. Okay, so we can consider it as frame or chassis. Okay, both are same. We can call it as frame or we can call it as chassis. So now the first topic is frame or chassis. So a frame or chassis is the most basic and the skeleton for the entire vehicle. So this frame acts like a skeleton or the outer structure of the rover. It creates support for all the other systems. It also provides protection for the driver. Okay, so easy way how you can understand this is, for example, if I ask you to draw a house, what will you do? First, you will draw something like this and you will draw like this. If I ask you to draw a hut, am I right?
Yes, Akka.
You draw like this. So what is this? This is the outer structure. So all the thing that you're drawing here is the outer structure of the hut. In the similar way, every rover has an outer structure. That outer structure is called as the frame or the chassis. Did you understand?
Yes, Akka.
Yeah.
Yes.
There are a variety of frame designs to choose from. So we have n number of designs. For example, if you see here, this is the go-kart frame. So this, it looks like a go-kart here. Then we have a trapezoidal frame. See here, it looks like a trapezium. Everything here looks like a trapezium. So that is a trapezoidal frame. Then we have a triangular frame. Here you can see the triangles here. So not only these three frames, we have other frames also, like we have cuboidal frame. So we have other shapes also. But for every rover, we can't use whatever frame we like. We can't choose like that. So while choosing a frame, we have to, or while using a frame, we have to keep in mind a few important points. So the frame we choose depends upon many factors, like what is the main objective of the mission? Okay, what is the main objective of the mission and what shape we want our rover to look like? So based upon all of those factors, we have to choose the frame. We can't choose whichever frame we like. Okay, am I clear?
Yes, Akka.
Yes, Akka. But the most strongest frame is trapezoidal frame. This frame is very strong. So many of the scientists or most of the rovers use a trapezoidal frame. So that is all about frame or chassis. So now next we are going to talk about suspensions. So suspension is another important part of a rover. So for wheeled locomotion, the main component is suspension mechanism, which connects the wheels to the main body or the frame. So easy way to understand the suspension is, see for example, This is the frame or this is the chassis, and here are the wheels. So suspensions connect the frame to the wheels. Okay, am I clear? The wheels get connected to the chassis or the frame by the suspensions.
Okay.
Did you understand?
Yes, Akka.
Yeah.
Yes.
And also another important point about suspension is that while you're riding in a car or bike or any vehicle, sometimes we experience the bumpiness, like when we are traveling in difficult roads, like
Yes, Akka.
on the rocky road or
Speed
speed breaker,
Speed
like
breaker.
that. We sometimes experience the bumpiness, right? But if there are suspensions, the journey will be very smooth. You don't feel that bumpiness, okay? You won't
Because
be able
of
to
the
feel the
suspension.
bumpiness. Yeah, because of the suspension. The suspensions make the journey very smooth. You won't find it difficult. You will not get any inconvenience while riding. So it makes the ride very smoother. So here we have different types of suspensions. We have hydraulic suspension here, if you can see. This is a hydraulic suspension. Then we have the leaf spring suspension. See, it looks like a leaf. That is why it is given the name as leaf spring suspension. Then we have the normal spring suspension. And this is the long arm suspension. This is the coil over suspension. And this is the wishbone suspension. So these are all the different types of suspension. Different vehicles use different suspensions. For example, heavy vehicles like trucks and trains use leaf spring suspension. For comfortable driving, cars use a complex spring mechanism. Okay. So we know generally rovers are driven on the rough surface, which consists of different sized stones and sand. Am I right? On the surface of the Martian terrains,
Yes, sir.
we have rocks and stones. So rovers travel in those rocky terrains. So for this reason, that is why car suspensions cannot be used in a rover. The suspensions which we use in cars or trains or trucks cannot be used in rovers. So rovers have different types of suspensions. So those suspensions have few requirements. First of all, the suspension should be simple and lightweight. Next, their connections should be without spring to maintain equal traction free on wheels. Okay, so the suspensions that we use in a rover are entirely different than what we use in our vehicles here. But mostly in a rover also we use wishbone suspension because it is very strong suspension. It's also very easy to manufacture and all of that. So mainly wishbone suspension is used. Okay, for example, if you see here, see. Yeah, if you observe here, this is the upper control arm, this is upper ball joint. So just this is shock absorber. These are all the parts of this. Okay, these are all the parts of this wishbone suspension. I hope it's clear.
Yes, sir.
Yes, sir.
Okay. So this is all about suspension. This is about frame and this is about suspensions. Now moving on to the wheels. Wheels play another important role in a rover. So rovers should be able to run over different types of surfaces. Also, the wheels must be made from materials that can withstand the extreme environment. Okay, the wheels should be made of strong materials. Otherwise, what will happen when the wheels go over the rocks and the sand?
Good puncture.
Yeah, they get punctured or they get like torn in between or they get broken. So the wheels should be very strong. So one thing you need to understand about space rover wheels is that they are not like the things that you see on Earth. So the wheels that we use on Earth cannot be used for a rover in space. So first condition that we need to remember is we should not use inflatable tires. If we use inflatable tires, what happens? We need to keep on filling the air into the wheel. Am I right? We have to keep on
Yes,
pumping the air. But can you pump the air in space? Is it possible?
No, Akka.
No, we can't pump the air in space. That is why we should not use inflatable wheels. We should use non-inflatable wheels, like the ones shown here in the pictures. We have to use these type of wheels. Okay, so NASA's Perseverance rover has 6 wheels made of aluminum, designed to drive across the sandy, rocky, and hilly terrains. Okay, and another important point is the rover's wheels should be lightweight and durable. It should not be heavy. Wheels cannot be more than 40% of the total rover weight. So if we consider the entire rover weight, these wheels should not be more than 40%, which means it should be less than 40% or exactly 40% of the total rover weight. Okay, are you able to understand?
Yes, sir.
If you see here in this, you know the Curiosity rover and the Perseverance rover, right? So those two rovers, these are the wheels of Curiosity rover and Perseverance rover. These are the wheels made of titanium. Okay, so these are the wheels made of titanium. And you know this wheel here, this is called as the wheel here. This is called as mesh wheel because it looks like a mesh. Is it not? It looks like a mesh. So this is called as a mesh wheel. Okay. Yeah.
Yes,
So
sir.
this is all about the basic structure. So today we have covered about frame, suspension system, and wheels. So you can consider this topic as a small course which you are doing because this is a part 1. See, this is a part 1 of Rover Designing. You can consider it as a small course. So again, in the further sessions, we'll be learning more about Rover Designing. We will complete the process of Rover Designing. We will learn more and more topics related to the Rover Design. So today we have covered about the frame, the suspension system, and the wheels. Did you all understand these 3 topics as part of
Yes,
the
sir.
design?
Yes, sir.
Yes, sir.
Okay, so now I have a small video to show you. But before showing that video, I would like to give a few small introduction. So what happened is, you know, the rovers which are sent onto the Mars, right, on Martian surface. So after a few years, what happened is, the wheels of the rover experienced wear and tear. Means some part of the wheel got broken. So what NASA did, NASA redesigned the wheel. NASA reinvented the wheel, or we can call it as NASA redesigned the wheel. It redesigned the wheel in such a way that that wheel will never break again, or that wheel will never experience wear and tear.
Never punch again.
Yeah, never get puncture again. Okay. So now let's watch that video on how NASA reinvented the wheel. So it's very interesting video. Just watch it now.
Okay.
NASA has spent half
We
a
can hear
century
Akka.
literally
Yeah.
trying to reinvent the wheel. On Earth, wheels with pneumatic tyres have proven very effective and efficient, but the Moon and Mars are not very friendly to the average car tyre. NASA has designed all sorts of wheels and tyres using various materials, but even their latest creation, the Mars Curiosity rover, with state-of-the-art wheels designed specifically for Mars, started taking damage after moving around on Mars. engineers began to notice significant wheel damage due to the unexpectedly harsh terrain. So NASA had to go back to the drawing board and come up with new wheel designs.
So see here what happened. Here it is broken. The wheel is broken.
It's
Can you
punctured.
see here? Not punctured, it is broken. It is
Okay.
broken here. So that is why the NASA scientists have reinvented another wheel. This one is a reinvented wheel.
Redesign.
New wheel designs. NASA Glenn Research Center has just reinvented the wheel, a new tyre that can go back to its original shape.
See, now even though it is exposed to sharp object also, it will not break.
After having undergone deformation. This invention was possible thanks to a shape memory alloy.
See, even if you heat it, nothing will happen.
Shape memory alloys are materials that can be stretched and reshaped by applying heat to the source.
It will just compress again. It will not break or nothing will happen.
The material is a nickel titanium wire mesh.
See here, they are doing testing. Like they are keeping big rocks in the middle and they are testing whether this wheel will be able to move on the rock or not. You are able to understand this video?
Yes, Akka.
That they are testing whether this wheel could climb on the rock or not. Let's see what happens.
Yes.
Let's see if it will be a success or will it break.
Which looks like medieval chainmail. No matter how many rocks it rolls over, this super elastic tyre will return to its pre-deformed shape like nothing else.
See, nothing has happened. So this is a new type of wheel which NASA has reinvented. The normal wheels means they will break when they climb onto the big rocks. But this wheel, nothing happened to this wheel. Okay?
Okay.
Never happened.
Okay,
This technology represents the latest evolution of the spring tyre, which was invented by NASA Glenn and Goodyear and inspired by the Apollo lunar vehicle tyres. After building the shape memory alloy tyre,
See, they're doing another testing. They now kept more number of rocks.
Glenn engineers sent it to NASA's Jet Propulsion Laboratory Mars Life Test Facility, and it performed impressively on the punishing track, going round and round testing
Wow, see, nothing has happened. It is going on very smoothly.
over various rocks and materials. Though still under development, NASA sees great promise for the
We have seen this in the PPT, right? The mesh tire. I talked
yes,
about the
Akka.
mesh
It is
tire.
made up of aluminum.
This is the mesh tire.
new alloy mesh tyres. They are not only more durable, but they conform to the terrain without sinking, and they can carry heavier payloads at moderate to high speeds.
So these are made up of alloy tires.
The hope is that one day they will not only improve the lifespan of unmanned rovers, but will be used on manned vehicles as well. Anyway, that's the end of this video. Thanks for watching, and we'll see you next time. Bye bye.
So that is with that video. Did you understand what is being said in that video?
Yes, Akka.
Yeah. Okay. So this is what we discussed in today's session. In the introduction to Rover Design, we talked about the frame and wheels and suspension. So now what I want all of you is, each of you should give like at least 1 point what you've learned in today's session. Each of you, one of you start. Just any point that you have learned in today's session.
A rover is designed based on what type of terrain it's going to be moving on. Like on the moon, it's designed for the moon's terrain, and on Mars, it's designed for Mars terrain.
Yeah, right, okay. Next. Just feel free, just express your views on what you have learned. Come on, one of you, just unmute your.
ISRO created the rover called Redesign.
Okay.
ISRO created the rover called Redesign.
Yeah, India is over, but yeah.
Akka, and there are two types of rovers, Akka. One is the human controller, and other one is automatic.
Yeah, human powered rover and autonomous rover. Okay. Next. Any other student? We have few students here. Right? What about others? Pradhamini, Ditya, Krisha. You can also give a point. What you've learned. Those who have already spoken can again speak. It's not an issue.
The tires on rovers are different from the tires on Earth because they need to withstand all the rocks on different planets. So they made them out of a titanium alloy.
Yeah, right. Okay.
Akka, Artemis Mission used human-powered rover.
Yeah, okay.
Our India also made a rover,
Yeah,
but
it's
it
known as
was
Pragya.
fed to the
Yeah.
Chandrayaan-2 mission.
Yeah. It got crash landed. Okay, so I hope you've understood about rover designing. It's not entirely completed, but just based on the topics what we have discussed today. I hope you all have understood.
Akka, next
Yes,
week
Akka.
will you teach the part 2?
Yeah, this is the part 1. So in the next Sunday, next session, I'll be going on to part 2. Like we'll go further more into the rover design.
Okay.
Okay, Akka.
Yeah. Okay, so that's all for today's session. Thank you all for joining. You can leave.